In this module, we will be learning the different information processing approaches, IPA from a developmental perspective, and how attention, memory and metacognition abilities develop in children. Behavioral scientists considered human behavior in the lines of stimulus and response, disregarding any mental causal agents. According to them, only what was observable was deemed to be empirical. Information processing approach to cognitive development projects that human beings process sensory information that they receive from their immediate environment mentally and not merely respond to sensory stimuli. Mental processes take place in the sequence of registering, storing and retrieval information and is precursor to any behavioral outcome, be it that of activation or inhibition. Now look at the models of information processing. The initial ideas that emerged as the information processing view were that of computer like cognitive systems that considered brain as a storage system. This store view emerged in the late 1960s and the early 1970s. The store view considered sensory register and memory at its core, while another relatively recent view is of connectionism, related to the understanding of cognitive change and functioning. The store model was given by Atkinson Shiffrin in 1968, and this is a model of information processing system. It comprises of a sensory register, working or short-term memory and a long-term memory. The sensory register holds information of sight, sound, touch and olfaction, storing this information very briefly. Working memory or short-term memory is more restricted and focused. It is the information we make sense of and keep in store for operation. For example, if the line you read in this module says to turn over to page 3, after you complete this paragraph, you will be using your working memory to store that information and retrieve it for jumping to page 3. Central executive is a part of working memory that directs the flow of information. It sifts the new information on basis of meaning for importance or significance, coordinates between old and new upcoming information, and monitors the strategies to accommodate both. The central execution is also considered or referred to as metacognition. Long-term memory is where information is stored with relative permanence. It is the largest storage area. For example, mathematical concepts studied in class 7 that you still remember are stored in your long-term memory. The theory of connectionism deals with the processes that takes place in the brain when children master new skills or perform a mental task. Thus, this theory deals with changes in brain taking place with experience and growth. Neuroscientists use computers to stimulate brain neural networks. These connections are artificially manipulated or strengthened, and their effects on cognitive capacities studied. These artificial neural networks simulate the brain's complex neural networking and structure. It comprises of an input layer responsible for encoding of tasks, one more or more hidden layers storing information needed for performing a task, and an output layer that generates a response. The human brain works simultaneously with its different units working all together in a parallel fashion. This is why the artificial neural networks are also called parallel distributed processing systems. Now, the developmental theories of information processing. The models that we just mentioned only explain how information may be processed in the human brain, but neither takes up a purely developmental perspective. There are two basic theories that take a developmental route. The first is Case's Neo-Piagetian theory, and second is Siegler's model of strategy choice. The neo-Piagetian theory incorporates Piaget's stage theory along with certain changes in all the stages of development described by Piaget. It is a theory of cognitive change and what factors influence change at each of these levels, that is sensorimotor, preoperational, concrete, operational and former operational. The first factor contributing to this change is the brain development of the infant. As the infant is growing, it undergoes varied changes in the brain structure, forming newer connections via synaptic growth and discarding redundant ones via synaptic pruning. Cognitive capacities lie in a particular bracket for every age determined by number and strength of these neuronal connections. The second is practice with schemes and automation. Automation of information takes place when a particular processing is so well rehearsed that it requires minimal mental cognitive effort and space such that the schemes become well embedded in and easily retrievable from memory. Case in his studies with children found that they show increase in capacity to coordinate the number of tasks dimensions with increasing age. This theory has been applied to arithmetic word problem tasks, story comprehension, picture drawings, sight reading musics, handling money and interpreting social situations. The theory proposes the concept of continuum of acquisition, which holds fast the view that many understandings appear in specific situations at different times rather than all at once. Siegler's model of strategic choice has been proposed that bases itself on more recent evolutionary perspectives of cognitive development. According to Siegler, the strategies that a child may choose or select to solve a challenging problem may be determined by experience. Certain strategies are more frequently used and survive the test of time, while others die off. Variation and selection is claimed to be an evolutionary characteristic of the mental strategies as well, and not just physical attributes. The research Siegler used to study these strategies were known as microgenetic research, designed by presenting children with problems to solve and observing the strategies used by them. Children followed overlapping wave patterns for basic math facts. This involved trying varied strategies and progressing to more advanced forms. Children select strategies on the basis of accuracy and speed. They try varied methods and then choose the best ones, refining them or combining methods to reach upon the most accurate and speedy ones. That is the most efficient strategy. Siegler's finding regarding the children's strategies for problem solving depicted that children vary their methods even when presented with the same problem twice or a similar one. Also, no two children use the same strategy. He implicated this variability in strategy selection to be an adaptive developmental feature, since these may contribute to newer ways of thinking and cognitive advancements. Now we will deal with attention. Attention system is the most basic and primary cognitive system for the input and registering of information or any higher order cognitive functioning. Attentional system is what mostly filters incoming information, participates in selecting information or orienting sensory organs to external stimuli. Sustained attention is an important contributor to goal-directed behavior. The child needs to be less distractible by novel stimuli and have increased capacity to hold attention to single particular event, something like building a train track from pieces. Infants' attentional responses are judged using eye-catching novel stimuli, slowing of heart rate, which is an indicator of sustained attention, longer looking time at a particular toy, object or event, it has been seen that infants and young children focus longer on complex visual stimuli like movie, video, etc. It is in toddlerhood that researchers have claimed a child to display goal-directed and intentional behavior. Sustained attention is also associated with selectivity of attention. Selective attention involves focusing on particular information or stimuli in the environment while inhibiting other competing ones. This ability for selective attention increases with age. Researchers have found that selectivity of attention increases sharply between 6 and 10 years of age. As mentioned before, sustained attention depends on inhibition. Sustaining attention doesn't simply involve orienting and focusing attention towards stimuli. It also involves active inhibition of orientation to other distracting stimuli. We are constantly bombarded with multi-sensory input from our environments. If we did not master inhibitive control, every other stimulus would distract us from the course of action being pursued. Mastery in complex inhibitory tasks in children comes around early to middle childhood. Miller and colleagues worked with 3 to 9-year-old children on their attentional strategies. She proposed that there were 4 kinds of deficiency, each specific and corresponding to every age group. She enlisted production deficiency, that is, the preschoolers rarely ever engaged in any strategies. Control deficiency, children produce strategies but sometimes and very often inconsistently and thus display not controlled execution of these strategies. Utilization deficiency, when young children use strategies consistently but lack any significant progress or improvement in performance. And finally, effective strategy use displayed by mid-elementary school years, in which case there is a consistent use of strategies leading up to improved performance on the task. Planning. Goal-directed behavior begins in toddlerhood and progresses in its complexity until adulthood. The difference between goal-directed behavior and its execution between toddlers is not just of complexity but also of control. The indicators to planning, which means strategizing and thinking ahead in time of regarding the allocation of resources to particular task units, are evident even in infancy, though not mastered until ages 7 to 9 years. Research done on 2 to 3 month old infants has displayed precursors to effective planning. This skill is usually strengthened with practice in everyday situations like parents teaching children to plan their day or week ahead or planning a vacation. Planning discussions with parents during the age of 4 to 9 years was found to be related to planning competence in adolescence. Attention is said to improve memory strategies for retaining information in the working memory store and its transfer to the long-term store. Memory retention increases with age as the baby grows its capacity to store information. Even though infants hold memory capacities and this capacity only grows with time, it's not until middle childhood that their strategies are efficient and mastered. Let's look at the strategies for storing information. The basic strategies used by humans to store information to the working memory or even long-term memory system are rehearsal, organization, and elaboration. Rehearsal involves repetition and rote memorization. It might involve somewhat deeper processing like organization. It has been found that to store information more effectively, there is an innate tendency to group and categorize objects when presented randomly. Even infants hold the tendency to group objects and beings in categories even if it is superficial. Even as old as 7 to 8-year-olds, much times show deficiencies of inconsistency in rehearsal, and even when they use these techniques, they are not always successful on the task. It is found that it is between ages 8 to 10 years that in children, organization is used successfully and consistently. As the brain develops in case of older children, the ability to apply multiple strategies simultaneously increases. This results in much more speedy performance on recall or memory tasks, as well as experimentation with different strategies. The child may arrive upon particular strategies that may be more effective and productive in certain conditions, while others may be more effective with different other tasks. Children start using elaboration by end of middle childhood, and it further becomes more popular and productive towards adolescence. Children might derive associations between two events, objects or words to hold them both in memory, even when they do not belong to similar category or hold perceptual similarities. The third component of memory is retrieval. Retrieval of information from the storage facility of brain involves recognition, recall, and reconstruction of information. These are the three forms in which retrieval of stored information is studied. Recognition and recall. Habituation research provides a rich pool of data and evidence on recognition capacity in infants and even neonates. Though the number of stimuli that can be recognized at one point of time only grows with age, the near adult level of recognition is achieved almost during the preschool years. Recognition is implied to be an automatic process considering its innate nature as observed in very young infants and its tendency to grow at such a fast rate and mature as early as preschool age. While recognition begins early, recall of stored information is studied to appear by the end of the first year, that too for memories which are strongly cued. Deferred imitation is implicated in recall memory research, and it grows rapidly by the end of 6 months of age. In early childhood, the rate of recall is drastically poorer than the rate of recognition of previously presented stimuli. Language development during the preschool years improves recall rates drastically. Language development research stresses the importance of enhanced mental representation of objects and events as child begins to use language effectively. Thus, it is implied that better representation leads to increased performance on recall. Reconstruction. Reconstruction is used when a large amount of information needs to be stored, and rote learning may also not help. For example, preparing a long answer type question. Here, instead of learning word by word, students make associations and meaningful connections, filter information for meaning and concepts, and reproduce the same in their own words, which might not be identical to the material or books the students studied the topic from. Children also reconstruct using strategies like condensing, integrating, and adding information. By 5 to 6 years of age, children remember gist and important segments of stories while forgetting or leaving out the unimportant particulars, sequencing the events in order and a logical fashion. This gist is also referred to as fuzzy and vague version of a story. This gist carries the essential meaning of the sequence of events that have taken place. It has been seen that despite the fact that adult memory capacities can hold verbatim of stories, there is an evident bias towards these gists. The theories abiding this view refer this theory as the fuzzy trace theory. Knowledge and its width has been claimed to improve memory, and better storage by increasing the information's meaningfulness and hence deeper semantic storage. Knowledge is thus considered after many studies done in this area as an influential source of improved memory and processing of information. The relation between memory processing and knowledge is now believed to be bidirectional and supports each other. Scripts are general descriptions of what occurs when it occurs in a particular situation and are formed out of interaction with people and objects in the immediate environment. These scripts have socio-cultural influences as well. Every day and the wide knowledge based system that each individual holds is stored as semantic memory. Semantic knowledge grows out of episodic experiences, though eventually the individual holds little recall of particulars about how or when did he acquire the knowledge, and only the knowledge or information remains. For example, knowing the capital of India, scripts are said to support taxonomic and categorical information which children usually master by 7 years of age. Metacognition. As the child grows, the child's knowledge and skills become more deliberate and controlled. The child eventually develops great awareness regarding his own problem-solving capacities and strategies and develops insight into these processes involved in mental thought. This awareness in thought is known to be metacognition. Just like attention and memory, metacognition also grows during childhood and is associated to the development of what researchers used to refer to as the theory of mind. Theory of mind is considered to be a mind reading of people's intentions and the insight that other people possess an intentionality that may or may not be different than one's own. Metacognitive processes include knowledge about cognitive capacities that one may have. Initially, developmental researchers propose that it is in before the age of 4 years of age that children develop a theory of mind, but later experiments proved that it wasn't so. Young infants also displayed clues to the theory of mind and an understanding of internal representation of objects in other people that may be different than theirs. While preschoolers' knowledge of working memory is limited, school-age children have more complete grasp of cognitive processes. By the age of 10 years, children can make difference between remember, know or understand means better certainly than words like guess, estimate or compare. School-age children are more aware regarding mental strategies than preschoolers. Theory of mind in infants and early childhood has been studied using false beliefs to understand children's understanding of intentionality and mental states of other than themselves. As mentioned previously, violation of expectation and eye tracking methods are used to record child's responses. Cognitive self-regulation is another metacognitive activity which involves monitoring strategies employed with respect to the problem and the probability of solving it with success, checking outcomes and reallocating resources in case of unsuccessful attempts. Cognitive self-regulation is a higher order cognitive function and is considered to be a strong predictor of academic success in adolescence. Parent-child interaction is a good determinant of effective cognitive self-regulation. Using methods such as explaining effective strategies like telling why to do a certain thing and not just what to do is particularly helpful. Children whose parents guided them and helped them with problem solving back at home were much more resourceful than multiple approaches and strategies to a problem. Applications. Application of information processing approach as an area of child development is found in development of children's academic skills. The focus is on identifying specific cognitive skills in different areas of academic functioning, strategies that will improve the child's performance, generating awareness between good and poor skills, etc. Based on research in this area, developmental psychologists hope to design teaching methods that may improve children's learning capacity. Many developments have been made in reading skills, mathematical skills, and scientific reasoning. To summarize it, information processing approach focuses on mental processes called cognition. It deals with how performance on a task is regulated by internal cognitive abilities that develop and mature over time. The precursors of this ability show from infancy. Human beings are gifted with cognitive and metacognitive abilities that distinguish them from other beings. These processes include attentional system, which incorporates selection of information, focusing and maintaining attention, and inhibiting as well. Memory system is aided by different processes of attention and is responsible for storage and retrieval of information, having varied components: sensory memory, working memory, long-term memory. Finally, the higher order cognitive system is the metacognitive system that children develop through experience with solving problems and controlled guidance. It matures later than all the other systems and deals with awareness regarding strategies employed by self and others. The central criticism of information processing approach has been that it has been unable to develop a wholesome and comprehensive model of processing. It organizes cognition into separate components, and the problem has been in reassembling these components. Imagination and creativity is one aspect that a computer model of cognition cannot explain. These topics are more human and are gaining considerable popularity in research and the information processing approach, and has yet to develop an explanation for it. Its perspective is accused to be linear and logical to explain such real-life experiences. Despite these drawbacks, the approach displays a promising future in areas of cognitive neuroscience and development. Thank you.